Oh, yeah, you're right. No. Okay, so now that you have this, now that you separate everything, you do this, you get 3. So, then you combine this all together, 4x minus 3x.
Before we do that, over here, right, what can we simplify this to? Square factors. What you, but also, what else? Like,
Because you're trying to get it so it's hard.
so remember, I think I told you yesterday, what if we have variables and then a group? Are you trying to find how many pairs of like that you make? So how many pairs of 3 do you use?
Okay, so
How many groups of 3? Just one, exactly. So it's going to be y to the 1, just y.
you make it?
Because that's
Last time they just stick with soccer.
so then this whole thing, whole screen right here, if you say 2, Josephine, our handwritings are very similar. But it's kind of weird. Anyway, so times, and then we can simplify this to u root of y to the 3rd.
Okay, so we're gonna simplify the rationalize the radical. So
So then this just simplifies y.
I'll let Benjamin finish up.
Minus 3 y times cube root of y minus cube root of 3. And then this. Exactly. And so then over here is for y actually well, x, y, then times the cube root of
Then we do the rest for. So, we want to do the same thing with plus. We want to see if we can split it up into anything that is like a perfect overall. So, what can you split this up to? Yeah, just have to. So, what do you think? Yeah. 2 times 2 times 2 times 2 times 2. No, 1 doesn't work. One doesn't work, but it doesn't change anything.
Okay. Kyle, just come back after school. I have a lot of lessons to cover, but you can watch the old recording, and if you still need help, you can ask me.
Can I just explain about the whiteboard?
Oh, now I get it.
In the back. In the back. I'm
Okay,
gonna.
let's just mix it up.
all of them.
See that? So.
So, and keep it low, quiet. So, rationalize the radicals. So, a lot of time that a teacher told you says, in algebra 2, we tend to tell you says, you should not have a radical on denominator. You should always rationalize the denominator radicals. But the truth is, they are the same answer. You're not changing the answer, you're just changing the format of the answer. So technically, you don't have to rationalize a radical to advanced math. I mean, usually you don't have to. Sometimes you even have to rationalize the numerator. On different cases, in calculus class, we have to rationalize the numerator. So that's the things that a lot of time that we tended to tell you one thing, but when we go on to a higher level, we start telling you says, okay, it's no longer that it is. But here we had to just know in the technique, what does rationalize mean? Just means get rid of radical in a certain places. So usually you rationalize the denominator, usually. But sometimes you do have to rationalize the numerator, okay? So here's the things that we have to pay attention to. So if I have a square root of 7 over square root of 5, the problem is there's radical here. And we had to rationalize it. Now if I want to rationalize it, I just multiply the same radical as the bottom. But I cannot just multiply by that. So I don't multiply square root of 7 over 7. I want to make sure this are the same. Okay, so in this case, it's going to be square root of 5. It's going to be square root of 5 over square root of 5. Then you can simplify now, inside by inside, outside by outside. That's going to be square root of 35 over 5. Because square root of 5 times square root of 5 is square root of 25, and simplify it down to 5, and that's something that we know. So square root of 7 times square root of 5 is the square root of 35. Square root of 5 times square root of 5 is 5. Now we got rid of radical on denominator. So this is a radical on denominator. It's not okay right now. We need to rationalize it. We need to get rid of radical and multiply by the same denominator as this one. And then multiply top and bottom, because this is essentially what? 1. So you understand that 1 is very powerful, right? 1 is one of the most special number in Euler's formula, right? What was the Euler's formula? E to the I pi plus 1 is equal to 0. Okay, so then that 1 is very special, because anything multiplied by 1 is going to be the thing. Now the second thing is today we're going to talk about also that part of I. Question about this part. Okay, so I'm going to give you one, ask you to rationalize it. So I'm going to give you, let's say, this is too easy. I'm going to give you one that's a little bit harder. Square root of 7 over square root of 45. 45. Now here's the thing. I would strongly suggest you simplify the radical before you rationalize it. So anything can simplify first, I will simplify first before I rationalize. Okay? So this one's a little bit more difficult. See, anything you can simplify first, I will simplify it. And then you go on to rationalize, you know? So my hint is that 45 is kind of big. But you can do it. I mean, regardless, you still can do the problem. Yeah. I don't know, it's right, I'll go over it. So there are a few ways to do it. I can multiply by square root of 45 over square root of 45, right? That's actually, you're gonna 45 times 7, that number is way too big. Do you see what I'm saying?
Yeah.
But how do I simplify square root of 45? Sometimes I can even put in one radical, but 7 doesn't go into 45, so that's useless. So what I can do is I can simplify first. So square root of 45 is equal to square root of 9 times what?
Square root of 5.
And square root of 9 is what? 3. So square root of 7 over 3, square root of 5. And now I still have a radical on the bottom. Now do I multiply top and bottom by what? Square root of 5, but not 3 square root of 5, because you don't need that 3. 3 is not what we're trying to get rid of. But even if you have that 3, it's not end of the world. We still can simplify it down, because that 3 is eventually cancel out. So I can multiply by square root of 5 over square root of 5. And then that's equal to square root of 35. And I here it's going to be 3 times 5 is what? 15. Now remember, this one inside cannot reduce, because one inside a radical, one is outside a radical. So they cannot be simplified any sort of way. A lot of people tend to be want to oversimplify. No, don't do that. Inside a radical, outside a radical is like, you know, it's like different countries. You cannot do anything with it. Got it? Okay. So this wasn't an issue, right? This is something that we learned in geometry, I think. Do we learn this in geometry? Or pre-algebra or algebra 1? Algebra 1?
Yeah.
Algebra 2? Okay. So now, here is, what if the radical is in two terms? That's to say, well, if I have 3 over 4 square root of 3 plus 5 square root of, let's say, 6. What happened? I still have a radical on the denominator. Okay. Daniel, the lesson you missed is kind of here. Where does it come from? Do you see it now? Do you see it?
Yeah, more or less. Get it, but I think I know.
Okay. So, Ariana, pay attention. You're zoning now. Okay. So, if you look at this, I have a radical on denominator. But how do I get rid of radical? Anybody have any ideas? I know you kind of do. But anybody have any idea how to get rid of 2 radical at the same time? Yes.
No, never mind.
Go
I
ahead.
was gonna say multiply them by like their negative counterparts, but I don't think that's right.
Negative what?
Like, they're opposites in terms of signs, but that's not right, because it's not gonna work.
Well, you're on the right track. Yeah, it's close. So, do you remember that when we're talking about factoring, we keep on talking about one type of factoring? I keep on really emphasizing on that. What is it?
No.
What is it?
The difference of a square.
Difference of a square. Now, I'm going to show you how difference of a square. And you are right, Josephine. Is you multiply by counterpart, but that counterpart is not doesn't name counterpart. It means actually the term start with a C. Do you remember? Thank you. Conjugate. Why is it conjugate? Why is conjugate is important? So you remember that. You remember this one, right? A plus B times A minus B is equal to what? What's a fact? Which one factor to this? So this resemblance to this. And you just had to create the, what she said, the counterparts with a negative sign. But there is a name for that. Conjugate, thank you. So what I'm going to do is I multiply this by conjugate. So this is a matching with A, this is a matching with B. I'm going to do is create this happening. So which is the counterpart, which is the conjugate. So it's going to be 4 square root 3 minus 5 square root 6. Are we okay here? But you cannot multiply just the bottom, you have to make sure it's to the top. So, are we okay here? Now, we have this part. It's also A, this is also B, but we know this one, A plus B times A minus B. What is that result? It's equal to what? Well, it's equal to 4 square root 3 square minus 5 square root 6 square. Does that make sense?
Yes.
Then the radical is going to go away, which is nice. Okay? So this is really powerful. So outside by outside is 3 times 4 is 12 square root of 3. And then outside by outside is going to be minus 15 square root 6. Remember, it's really easy to mess up the sign, so you have to get very, very conscious of what you're doing. So do you see that? Now, why is that important? Because square root 3 times square root 3 is equal to 3. So that makes my life easier. So in this part, I'm going to go down to here. I'm going to go down to here. So on the top, I cannot simplify anymore. So it'll be 12 square root 3 minus 15 square root 6 all over, well, 4 squared is 16, right? Times by square root 3 times square root 3 is 3, which is nice. Minus 25 times by what? 6. And then you say, okay, well, 12 square root 3 minus 15 square root 6. Double check my math. 48 minus 150, I think. So 102 over 12 square root 3 minus 15 square root 6. Now, for me, I don't like this answer as much. There is a reason why I don't like this answer as much, because sometimes on SAT, when after use quadratic formula, and they don't have answer like this. And some people tended to cancel, oh yeah, that's 102, I can simplify 12 and 102. But you cannot do that, because it's connected by subtracting sign. I know as much as you say, oh yeah, 12 and 102, that can simplify, but you don't want to do that because that's very risky. Yes? Negative what?
It's negative.
Yeah.
Because you said you needed-
Negative 102, thank you. So negative 102. So what I will do is actually I will using the split strategy, right? So when sometimes you have this, that I will make sure it's A over C plus B over C. Really depends, because when we deal with i's, that's much better. But that's probably unnecessary, but I'm gonna do it anyway. So 12 square root of 3 over negative 102. And a minus 15 over a plus negative over negative 102 square root of 6. Well, this is a negative over negative, right? So I'm just getting plus negative over negative, so that way I don't confuse the sign. This one I can simplify down to what? 6 and 51, right? 6 and 51, but can I simplify more?
Yes.
6. Oh yeah, you can go with 4, I think. Can I go with 4?
You can divide by
No. Can I go with
Go with 3,
3?
but that's not gonna be fully simplified.
Okay, so this is a 12. 3 is okay. Let's go with 3. 3 is gonna be what? 4 square root of 3?
3 over negative 34.
Negative what?
34.
34?
Yes.
And that can simplify more, right? So this is a plus, this is negative over negative. Can I divide by 3?
Yes.
So that's equal to 5. And then what is it?
It should also be
34?
Yeah.
Okay, square root of 6. And this one can simplify more, so it's gonna be what? 2 square root of 3 over negative 17 plus 5 square root of 6 over 34. Double check my math. Make sure I'm on the right track. So you can simplify more, and that's very, very essential. Because sometimes your SAT answer is in this form rather than in this form, because you're gonna search it, nothing will do anything. And some people tend to cancel out this, and that's wrong also. So make sure when your bottom is one term, you split up to 2 terms. That's very helpful when we do a complex number. Not very helpful here, but sometimes the SAT answers show up like this. Sometimes the multiple choice answers show up like that. They want you to know if you know how to simplify more. Okay? So let's give you one that you can do. Let's name one here. That's 4 square root of 6 over 2 square root of 5. No, actually, let's go with 6 minus square root of 8, something like this. So I want you to simplify this radicals. I want you to rationalize. Which is, I don't like the denominator. I want to rationalize the denominator. You can also rationalize the numerator in this case. So really depends. Like in calculus, I know Daniel's in my class. He sees case in both. We had to rationalize the numerator. In case we had to rationalize the denominator. So not all the time you rationalize the denominator. You have to pay attention to that. So I'm gonna block you a little bit. Okay. Too bad. Sometimes in my calculus, you see the whole board is one question.
Is that like two sides rotating?
Oh, that's not good. That's still baby stuff. Until next year. Daniel's how it. That's the whole problem. Take a whole damn board.
Oh, yeah. Most of the times. Really?
You cannot mess up one science.
That's a lot of that.
It's a time making math to do math. So remember, multiply by the conjugate. No, not saying. First, do the conjugate part, right. So don't multiply the wrong conjugate. You have to have the opposite signs. Okay. Somebody can help me what's the conjugate of this? Okay, Pablo, did I pronounce right?
Square root 6 plus the square root 8.
Right. You have to do that to the top and bottom. And then on the bottom, at here, you can FOIL it out. And you're gonna find out two middle terms gonna cancel. But you can do that. I'm gonna do it on the side to show you what's the difference. 2 square root of 6 minus square root of 8 times by 2 square root of 6 minus plus square root of 8. If I know my answer is 2 square root of 6 squared minus square root of 8 squared. So that's equal to what? 4 times 6, 24, right?
24.
Minus 8, I think. That's equal to 16. Or I can do 2 square root of 6 minus square root of 8 times 2 square root of 6 plus square root of 8. But that's gonna be 2 square root of 6 squared minus 2 square root of 48, or plus square root, and minus 2 square root of 48. Eventually the two middle term cancel out. Do you see that? Minus square root of 64, which is same thing as this one, so it'll be 12 times, let's do 4 times 6, 24 minus 8, that's equal to 16. So it's extra line where I can get it done in one step. Much more efficient. So on the bottom, it's gonna give me what? 16, right? On the top, it's gonna be 8 times 6. Does that make sense?
Yeah.
Plus 4 times square root of 48.
Yeah.
So that's equal to 48 plus 4 times 4 square root of 3 over 16. 48 plus 16 square root of 3 over 16. Can I cancel the 16 and 16?
No.
Why?
Because it's
connected by addition.
What's the best way to do it?
You write
A plus B over C, right? Bottom's one term, so 48 over 16 plus 16 square root of 3 over 16.
Yeah, it's a very quick.
That's equal to 3 plus square root of 3. It was a nice answer. If you don't simplify, am I gonna get this answer? But you have to recognize those answers are exactly the same with each other. Does this make sense?
Yeah.
How many of you guys got this? Okay, the other people have to work on it. Okay, 3 square root of 3. Okay, yes, question?
No, I just forgot to pull it up.
Okay, let's review a little bit. What is square root of negative 5 times square root of negative 5? Everybody got it wrong last time. It's negative 5 or positive 5? Huh? It should be what? Square root of negative 1 times square root of 5. Square root of negative 1 times square root of 5. And that's equal to I times square root of 25. That's equal to 5I squared. And I squared is equal to what? Negative 5, right? That's gonna be 5 times negative 1. Because we know two rules. How much time I have?
I don't know, I can't look at my phone.
That's true. That's a good one.
Benjamin. Benjamin said
Okay, so Benjamin's a boss.
10:52.
How much time I have?
10 minutes, 10 minutes.
10 minutes, that's good. Okay, so this one, we had to know two rule. I squared is equal to what? Negative 1. So you need to make sure you know this rule. Square root of negative 1 equal to I. So those are the two rules deal with complex numbers. And complex number is right in a plus bi form always. This is a real coordinate. This is actually a coordinate. A plus bi is a dot on a complex plane. It's not a line, it's a dot. Okay? And this, we can deal with it tomorrow more. Complex number. So, the real and complex value. So now what we're going to do is we're going to actually deal with this. We're going to say, well, what is 3i plus, I don't know, 4 over 3i plus 4 plus 6i minus 2, something like this. So, what's wrong with that? What is this lesson regards same as that lesson for us this? I'm trying to say is, what is I? Square root of negative 1. Do I have a radical on the denominator? Yeah, I did. What is that? That's equal to 3 square root of negative 1, right? Plus 4 over 6 square root of negative 1 minus 2. Is that a radical on the denominator?
Yeah.
So technically, I still need to apply the previous lesson, right? But I don't want to change in this form because that's not helping me. I stick with I. I love i's. So this one, I'm going to go back to here. We're going to say, okay, well, this is the same thing as this, right? This is probably the precursor of this one, right? So can I do, can I start with 3i plus 4 over 6i minus 2? Can I multiply by the conjugate? Okay, so what is the conjugate here on the denominator? Not the numerator, always pay attention to the denominator.
6i plus 2.
Right, 6i plus 2, right? So 6i plus 2. So now I'm going to multiply it out. But guess what? It's a difference of a square, right? So can I just use a simplified version? That's going to be what?
36i squared
36i squared minus 4, right? And on the top it's going to be what? 18i squared. And then
plus 30
plus
30i.
Yeah, I'm gonna take it one step at a time though. Plus 24i, you're right. And then plus 8. And then the I square, I'm gonna color code for you. So this is I square, that's in blue. Okay? So that's I square is what? I square is equal to negative 1. So that's equal to what?
Negative
18 times what? 18 times negative 1?
Yeah.
So 18 and 36 and the minus 4, and I'm going to do the negative 1 now. So negative 1 and negative 1, and then what happened? Plus 30i.
Yeah. Plus 8.
Hopefully the color coding helped. Are we okay?
Yes. Yep.
That's equal to, what happened here? 18 times negative 1 is what?
Negative 8.
Negative 18. Negative 18 plus 8 is what?
Negative 10.
Negative 10
Yes.
plus 30i, right?
Yeah.
And I here is what?
Negative
Negative
36.
14.
Negative 40, right? So can I split them? Negative 10 plus 30i. Can I split them? Split to, in this case, it's going to be negative 40 over negative 40. So that's equal to 1 over 4 plus 3 over 4 I. Does that make sense? Negative. So that's going to be this. And that's a plus bi form, which is a perfect form for complex number. Okay? Okay, so I'm going to give you questions. And those of you guys finish early, I want to teach you a new thing too. So 3i minus 2 over 4i plus 2. Okay? I want you to do this one. And if you finish, I'm going to teach you a new thing. So those of you guys finish early and get the right answer, come show me. It's on the video. Subscribe. Click like and comment.
If you enjoyed this live stream, make sure to subscribe and press that like button.
It's right here. Okay.
And leave a comment below detailing which part is your favorite. It's so corny. I don't think I can do it. But it works. It does.
Like, do you guys subscribe to channels? Yeah?
Sometimes.
It's just not mine. I know. It's okay, Nicholas.
No, I did subscribe.
I just don't watch the live stream. Well, I actually did watch 2 of your videos.
Really?
Yeah, I watched the test reviews.
Okay, cool. I don't know, I'm doing it right now. So, too fast for me. You can probably check if my answer is right. You're not fast. Minus 6 and 8. What'd you get? 5 plus 7i over 10.
Plus, would be negative.
Plus. No, it's plus. Good. Negative. 14 to negative 6 plus negative.
Oh, yeah. Okay. I overrode it.
Negative.
So if you want to answer it in the front, but if you don't want to answer it, it's fine. Over there. And A plus BI form. Okay, those of you guys got it done. I'm going to show you something really cool. I'm going to show you something really cool before you leave, which is, this is a very old-fashioned SAT question from a long time ago, back in the days. The question says I to the 73 power. And they say, what does I to the 73 power is? I to the 73rd power. 73rd power. 63. 70. Okay. So I to the 73 power. Do you guys know how to do that? How do you know it's -1? Huh? Well, okay, I'm gonna show you something really cool before you leave. So I, the first power is I to the second power is what? -1. I to the third power is I squared times what? I, so it's gonna be what? -I, right? I to the fourth power is what?
Positive 1.
It's I squared times I squared, so it's +1. I to the fifth power, basically I to the fourth power times I, which is what? I, right? So do you see the pattern? I to the sixth power is what? I to the 4 times I squared. So it's what? -1, right? So now you see the pattern. 73rd is what? Divided by 4, where remainder of what? 1. Remainder is 1, right? So that means what? You are the 72nd power is right here, and your 73rd power is what? I. Done.
What?
Sure.
Yeah,
I thought it was negative 73.
it's I. So the 72nd power is divisible by 4. 73rd is going to rotate back to here. So every 4 terms rotate. Tomorrow we're going to show you how that works. But you just have to know this by your homework. Yes. Yes. Well, I need you to focus in class though. I think that's gonna work more points. Let's see, I don't know, do you work? Oh, you look so tired, like when it comes to here.